We now have the spotlight session on the topic AI assisting AI, empowering humans and maximizing scale. This session will cover trends, innovation, and advancements in low-code, no-code models, and how is it going to disrupt the way a digital business operates beyond application development. Speaking on this topic is Silvio Savarese. Silvio is the Executive Vice President and Chief Scientist of Salesforce Research, as well as an adjunct faculty of computer science at Stanford University, where he served as an associate professor. And it's a pleasure to have you here with us this afternoon. Over to you, Dr. Savarese.
Thank you, Justin, for the introduction. Today, we're going to talk about unlocking the power of conversational AI. We live in a complex society. Today's technology and innovation offers amazing capabilities to its users, customers, consumers. But these capabilities come at the cost of being difficult to operate. Most modern tools require significant investment of time to learn, to deploy, to update. Let me walk you now through an example. Imagine you find yourself in the cockpit of a next-generation spacecraft, and you wish to travel from Earth's orbit to Saturn. How do you envision controlling it? Science fiction has conditioned us to equate futuristic technology with complexity. So you might picture rows and rows of blinking lights, shiny buttons, levels, and commands. It would certainly look impressive, but instead imagine a cockpit that is all but empty. You take a seat in a captain's chair and simply say, "Take me to Saturn." No buttons, no switches, no calculating trajectories. You don't even have to use some special code or syntax. Instead, simply speaking in a natural language you use every day. Imagine further that the ship asks whether you prefer the fastest route or a longer route, but scenic, that goes by Jupiter's Great Red Spot. After considering your options, you decide to take the scenic route. That's it. Your duties as captain are fulfilled. Scenic route confirmed, the ship responds. Back up. This scenario depicts well the main theme of this talk today. That is to deploy AI to empower users with new and complex capabilities while providing simple experiences. Let's now step back for a few minutes. Let's look at the path that led us to the present moment today. I'd like to offer a brief history of our relationship with tools. The use of tools stretches back to a period of time known as the Lower Paleolithic, some 2.6 million years ago. In this period, early humans had a natural affinity for smashing rocks and turn clumps of carbon into sharp-edged cutting stones. Archaeologists call these Mod 1 stone tools. They were handheld and applicable to a wide range of tasks. They were, in essence, the first human-made technology on Earth. And we've been a busy species, and in time, the Mod 1 rock gave way to sophisticated metal knives that we know today. And what makes the history especially interesting, though, is that our tools don't just grow in their power and range, they also become easier to use. A modern knife offers a sharper, sturdier blade. It affords its user a handle as well, and handles makes knives easier and safer to grasp. This pattern repeats through history. Here is another example. Early tools for measuring time were hourglasses. They are useful, but they only give an holistic sense of time. Then analogic watches were introduced with more accurate measurements and more functions. And finally, the digital age gave us modern watches, even easier to read and with even more functions like chrono, night display, and alarms. Another example is about transportations, from horses to bikes to cars. The latter being easy to learn, requiring no particular gifts of balance or endurance, and unlocking far larger and longer distances and higher speeds. So this pattern is clear. Given enough time and enough innovation, the reach of our capabilities is extended. Their ease deepens and their accessibility broadens. This is well illustrated in these 2D plots. X-axis measures capabilities. From left to right, we go from less to more capable and personalized tools. Y-axis measures how easily we can use and access tools. From bottom to the top, we go from easier to more accessible tools. And here is a take-home message. The best tools aren't just powerful and easy to use, but they are powerful because they're easy to use. However, as the 20th century gave rise to digital revolution, these patterns took on a more complicated form. It's true, our collective power has increased profoundly, But those advances have come to a price. Our tools have never been more complicated. Within the plot I showed earlier, modern professional tools generally clusters in the lower right quadrant. In these quadrants, tools offer high capabilities and customization power, but tend to be much more difficult to learn and to use. Consider, for example, a field like graphics design. Designer tools have historically been rather simple, with the basic operations of pens, pencils, rulers, and compasses. But today's software tools give immense more capabilities compared to what we can do with pencils and rulers. However, simply using those software tools requires a significant investment of time and effort. They are no longer as intuitive and accessible to use. Of course, there is always a market for digital tools aimed at novices. Simpler, more intuitive interfaces, gentler learning curves, and lower price points. Such alternatives, however, are often characterized by a frustrating trade-off. As accessibility rises, capabilities tend to fall. They may be easier to use, but the results are generally of a lower quality and offers less options for customizations and personalization. These are found in the upper left quadrant. We can call this the easy to use versus customization personalization trade-off. And why is this happening? Although the digital revolution has empowered users with new capabilities and powerful new tools, users also need to keep up with a new generation of technological challenges. First, overwhelming information. The sheer quantity of content competing for our attention is spiraling out of control. Text, images, video, audio, even tabular data. We no longer have enough time to consume everything we like. Second, increasing workloads. As industries of all kinds face tightening budgets and mounting competition, even highly trained experts are feeling pressured to do more with less. Third, trapped potential. We have a vast world of hidden talents who have ideas worth contributing, but they lack the expertise to implement them using existing tools. And last, the future of work. Today's tools are so specialized and labor-intensive that even moderate career transitions can have an unrealistic burden of upskilling and retraining. Thankfully, the last decade has seen profound advances in artificial intelligence, and the transformation proposition here is that we can now use AI to change the accessibility barrier for the first time. We can use AI to replace the complex and specialized skills of today's interfaces with the skills everyone already has. Conversation. For the first time in human history, AI allows users to use language or other modalities like gestures or visuals to express intentions and goals. This dramatically lowers the bar for learning how to use or deploy a tool. At the same time, AI gets back to users and provides proposals, insights, predictions that users can consume. And all of this can happen through a dialogue, through conversations, through a series of interactions. Here is an example. Suppose Anna is a web designer that wants to build a web interface. So Anna uses language to indicate what she wants. I need an input form with a text box, a submit button, and a cancel button. So the AI comes back with a proposal like the one at the top right corner. But Anna doesn't get what she wants right away. She wants the button side by sides and no logo. AI comes back with this. Just about there, but she has another small request about the color of the button. Anna isn't happy now. In this example, Anna doesn't need to learn anything about this web design tool. Just use language to indicate what she wants. Not only does the AI understand this request, but it also comes back with proposals, generate content, come up with a plan. This is similar to how the AI helped when she wanted to travel to Jupiter at the beginning of this talk. After a few iterations, Anna got exactly what she wanted. No boilerplate solutions, but a highly personalized outcome. So conversational AI takes us to the upper right region of the plot. It allows creating tools that are easy to use, but highly powerful and personalized. Conversational AI, it's more like a superpower than a tool, the kind of system that anticipates your needs, connects you directly to the best ways to realize them, and knows exactly how to execute whichever choice you make. In short, conversational AI is about turning a trade-off into a win-win for the first time. It makes entirely new things possible, all while lowering the bar to achieving them. The question now is, how do we get there? How do we achieve true conversational AI? Recent advances in AI are making true human-like interaction possible for the first time. This suggests that our goals of creating conversational AI are within reach. Among the central developments enabling this technology are large language models, also known as foundation models. These large models are similar in concept to the ones that have grown in popularity over the last decade for ability to recognize objects in images and translate languages. These are based on large-scale neural networks. But foundational models differ in a few key aspects. These aspects enable vastly expanded flexibility and applications. First, they are massive. Many of the largest examples feature billions of parameters, an order of magnitude larger than their predecessors. This boost provides the capacity that is necessary to consume very large corpora of training data, including volumes of text measured in tens of terabytes. Second, foundational models are characterized by an ability to pay close attention to their training data, for instance, large volumes of text. This allows them to recognize sophisticated connections between related words at larger scale. Consider this string of text, for instance. In contrast to previous models, which might lose focus before reaching the end of a sentence, foundational models can infer the importance of one word in relation to another across entire paragraphs or even pages. Third, perhaps the most powerful feature of all is that they can train themselves. This removes one of the biggest bottlenecks in the collection of training data for machine learning models, where a human supervisor must explain the difference between a correct and incorrect answer. In contrast, foundation models use a learning technique that relies on hiding in purpose some of the training data and trying to guess the missing ones during the training phase. For example, for language models, input text is masked at selected points, like here, there, and there. The model is asked to guess the content that best fills in it. Since the answer is already present in the data itself, no manual oversight is needed to administer the process. In this example, the model is guessing invisible and building in these slots, but these answers are not correct and negative feedback is given to the model. And here the model is guessing over in this slot, which is correct, and positive feedback is given. This allows the model to iterate at incredible speed and have its guessing abilities to achieve high accuracy levels as more and more examples are processed and feedback is provided. Finally, they are capable of massive training sessions that allows to process, for instance, every word of every article on, let's say, Wikipedia or other public text-based repositories. And that's when something astonishing happens. These enormous, hyper-attentive trained models develop capabilities that go far beyond what they have been trained for. For instance, they can finish sentences or write entire articles, answer questions, or summarize documents. But despite these amazing results, much of what makes conversational so powerful among humans still remains beyond the grasp of current foundational models. In recent years, research will need to overcome an even deeper set of limitations and challenges, many of which cut to very core our notions of intelligence. And this has been the focus of the research work in our organization at Salesforce. Chief among those limitations is the knowledge representation. A key limitation of foundational models or other common deep learning models is that they lack true understanding of the underlying subject matter, being art, politics, or economy. They essentially operate as in some kind of statistical mimicry. For instance, they might correctly answer a question like, who played guitar in the Beatles? Without truly understanding concepts like music, instrumentations or 20th century pop culture. Another key limitation is the lack of abstractions in presence of few training examples. In many AI applications, trained data are scarce and corner cases are difficult to collect. Imagine a car accident. In this case, it's imperative to design architecture that can learn and derive the principles at work with a few examples. This is the way we humans operate. We are very good at generalizing and borrowing from related experiences without requiring millions of additional instances to learn by brute force. Another key limitation is the ability to recognize the boundaries of their knowledge. Today's machine learning models have tendency to respond to any query with a strong confidence, and this can make confident mistakes. In the future, AI models must recognize their own gaps in awareness and knowing what kinds of questions to ask to the users if they become uncertain. This will help make systems safer and more transparent. Finally, machine learning models must address one of the oldest and most challenging problems in the history of AI, the acquisition of common sense. Simply put, common sense refers to the body of knowledge that we generally assume that our fellow humans possess. These are a constellation of unwritten rules that we rarely acknowledge directly, but we often take for granted. For instance, when we ask an assistant to help schedule an all-hands meeting, it's usually not necessary to specify that this meeting shouldn't take place at midnight, or on Sunday, or during the Super Bowl. Injecting common sense in modern AI is still an open, unsolved problem. So to summarize, it's clear that we still have a long road ahead of us. Despite these challenges, however, progress in recent years has been encouraging, and our research organization has made important contributions in various segments of AI: natural language, deep learning, and machine vision. And most critically, we have been advocating that conversational AI is a key enabler for a next generation of tools and products that are both powerful and easy to use. And in next slides, I'd like to highlight some of these. The main project I would like to highlight is called CodeGen. CodeGen is an AI model that automatically generates executable code based on simple test requests. Let's watch this video for more details.
Imagine a world where coding is as easy as talking, where you don't write a computer program, you just tell the machine what kind of program you want, and the machine generates the code for you. Well, now you can. We developed a model that lets humans and machines have a dialogue to write a program together. It's called CodeGen. We call this new coding paradigm conversational AI programming, as natural language understanding coupled with code generation. CodeGen takes English sentences as input and outputs working code to solve problems. In this demo, we will create an entire app from beginning to end without any coding, simply by having a conversation in English with CodeGen. The app we will create is a classic game called Snake. The game will allow the user to control a virtual snake to try and collect as many food points as possible. We will create all of the components of the app from scratch, except for the game engine and execution environment, which are provided as external dependencies. Examples like this demonstrate the potential of the CodeGen model to be used on low-code platforms for app development, or to create workflow and business processes. In our demo, the interactive interface is on the bottom left, and our game engine environment is on the right. We start by asking CodeGen to create a white snake represented as a sequence of 6 blocks. Put it in the lower left and show its length in the upper left. When the code is executed, you can see the snake appear on screen in the game environment, as well as its length. For the sake of time, we'll fast forward the steps of creating user keyboard controls to manipulate the snake, ending the game on collision with the map border, randomly positioning food across the map, and implementing point increments when the food is consumed. We can now see the result. CodeGen has built a minimal snake game, which runs directly in the browser and can be controlled by the keyboard. To see other demos and to learn more about how CodeGen works, visit salesforceairesearch.com.
So as you can see, CodeGen democratizes software development and makes it accessible to no-coders, that is, developers with no or little coding experience. But it can also be a game changer for the more expert coders and enable solutions that can help address key points such as efficiently express business requirements, understand existing codes with sparse or no documentation, or help focus on the design and creative aspects and skip the boring part. And I'm proud to say that CodeGen, within its 16 billion parameters, outperforms competing approaches like the OpenAI Codex on various benchmarks. You can try CodeGen on your own by downloading our open source version on GitHub. And this brings me to the end of this talk. I hope I have convinced you that conversational AI can be a game changer for designing the next generation of AI tools. Not only will these tools give users new powerful capabilities, they will also make these tools easy to learn and use. This is extending our ability to boost our creativity, accelerating our productivity, and overall augmenting our skills. And with that, I would like to thank you for your attention, and I would like to hand it over to you, Justin.
Thank you, Dr. Savarese, for a visionary talk on the disruptions AI will bring in the digital businesses.